Recording number 3, still building on the concept map. The various factors that occur with cardiorespiratory training that contribute to an increase in VO2 max. Okay, increases in VO2 max come through increases in cardiac output max and increases in AVO2 difference max. Okay. Right now we're still going to continue to focus on the cardiac output side, and remember that heart rate max does not change with training, so increases in cardiac output max must occur through increases in stroke volume max. Okay. Stroke volume is determined by preload EDV, left ventricular contractility, and afterload aortic pressure, which is P2. Okay, so any changes in the ability to reach a higher stroke volume must occur through one of these three factors. Okay, we talked about LVH, we talked about LVID. In this recording, we are going to talk about pulmonary ventilation, and on the next recording, we will talk about total blood volume. All right, so review from Chapter 7. Breathing frequency is the number of breaths per minute. Tidal volume is the volume of air that comes out with each breath. And pulmonary ventilation is frequency times tidal volume, or the total volume of air that's moved per minute. What we see with cardiorespiratory endurance training is an increase in breathing frequency at max, okay, an increase in tidal volume at max, and together they both contribute to an increase in VE at max. Okay, so after training, we are able to bring in and exhale greater volumes of air per minute. Okay, which makes sense because that allows us to bring in the greater amount of oxygen that's needed and to get rid of a greater amount of CO2 that's being produced. So how does pulmonary ventilation relate to stroke volume? Well, remember that stroke volume is affected by venous return. Okay, and we said that there are 3 venous return mechanisms. This goes back to Chapter 6, venoconstriction, skeletal muscle pump, and respiratory pump. Okay, and the respiratory pump is partially responsible for increasing venous return during exercise. Okay. So if we are able to increase our breathing frequency more and increase our tidal volume more, together those are going to allow us to achieve a greater VE. Okay? And with a greater VE, we have greater respiratory pump effect. Okay? And you should recognize this from your stroke volume concept map. If the respiratory pump has a greater effect, it has a greater effect on venous return. Okay? So I told you that there's 11 factors across the top of your map. Here are 2 more. Okay? And then remember, the rest of this you should know, right? More venous return means more EDV, more preload, greater contraction strength, greater left ventricular pressure, greater pressure gradient, greater stroke volume, greater cardiac output, greater VO2 max. Okay? Pretty simple. 2 more concepts coming off the top. With training, you're able to achieve a greater breathing frequency and a greater tidal volume at max. Therefore, greater VE at max, contributing to the greater VO2, the greater ability to use oxygen at maximal levels.